I'm Anil Kumar, and here is an interesting question on roots of polynomial equations. We are actually trying to solve polynomial equations, and this question is, if x cubed minus 4x squared plus kx equals to 0, what value of k results in two equal roots, right? There could be more than one value, so we'll write s here. So we'll say, if x cubed minus 4x squared plus kx equals to 0, what values of k results in two equal roots? Okay, so to understand the question, this is degree 3 cubic polynomial, so we are expecting three roots. Out of these three roots, we want the value of k so that two of them are exactly same. That is the question. What could be the values of k? Okay, so let's look into it. So we have this polynomial which is x cubed minus 4x squared plus kx equals to 0. We can factor x. If I factor x, we get x squared minus 4x plus k equals to 0. So from here, we know one root is at x equals to 0, right? So we have one root is at x equals to 0, correct? But we need two same roots. How about if I write k 0, I get another root at 0. Do you see that? Yes, that is possible. So we found one solution. Now the other solution we can find by making this term as a perfect square, correct? So let's see how to make this as a perfect square. That means if I make this term as a perfect square, then I have two exactly same roots, right? So this could be a perfect square if I have it like this. Think like this, x squared minus 2 times, let's say k, right? So 2 times square root of k times x, right? If we write like this, plus square root of k whole square equals to 0. That is the formula, correct? So in that case, what do we have? We have 2 times square root k should be equal to 4, right? So from here we can say 2 times square root k should be equal to 4, right? So 2 times square root k equals to 4, or square root k equals to 4 divided by 2, which is 2, and if we square it, then k is equals to 2 square, which is 4, correct? So it becomes a perfect square. So when we square 2, it becomes 4. So k could be 4 also. Do you understand? So k could be 4 also. So that is one solution. So we get k equals to 4 as another solution, right? So we get k equals to 4 makes two roots. Makes roots as what? So if I write k as 4, then I get this is minus here. So I get x minus 2 whole square as a factor, right? Two roots, right, as this. And we already considered that if x is a factor here, so which we really skipped after writing. So one root is at x equals to 0. So if I write, so let me do this part here again. Okay, so I skipped. So we'll do this one more solution here. So if I write k equals to 0, let's say if k equals to 0, then what happens? Then we have x times x squared minus 4x, and we can factor out x again. Do you see that? We can factor out. So we get here, if we factor out x times x, and this becomes x minus 4. So we get x squared. Do you see that? X squared times x minus 4. So we have a double root at x equals to 0, right? So we have another root. So another root plus 1 root at x equals to 0. So that is one solution, and this is the other solution, correct? So k could be equal to, so let's clearly write down our solution, and the answer for the question is k is equals to 0 or k equals to 4, right? If k is 0, then what is the equation? Then the equation will be x cubed minus 4x squared, right, equals to 0. This is when k equals to 0, right? And that could be factored as x squared times x minus 4 having a double root at x equals to 0. And if k equals to 4, then we can factor this as x times x minus 2 whole square. Let me write down the factor itself, okay? So that is how you can actually solve this question. I hope that helps, right? So it's a thinking problem. You have to really think how to get the value of k so that we have a double root. So starting from the assumption that was not an assumption, cubic equation should have 3 solutions. We are assuming that 3 are real solutions, out of which 2 give us 2 real roots, right? So we are just restricting ourselves to real roots, and those real roots could be found for k value of 0 and 4. I hope that helps, right? But for this particular question, we could also go for imaginary roots, but for this question, real roots are what we are getting, so that's okay. So I hope that helps. Thank you and all the best.